Hello friends, in this video we will talk about we will start talking about big data, and this is what we will talk related to big data. We will talk about evolution. We will try to understand the characteristics of big data and what are the batch operational and analytics tools in big data ecosystem. And then there is a 40 phrase come up by Accenture, which talks about types, technologies or tools, techniques and talent with respect to big data. And evolution of big data is started with Google. When they started implementing their search engine, they have started using MySQL, and as I have explained earlier, because of the challenges with the traditional RDBMS, they hit the roadblock after I think 1000 or 1500 databases using MySQL. It is not scaling up anymore, and also performance is not very good. So Google started working on new solution. Let me explain first what actually Google does and how these things can how Google try to solve that problem using these three new technologies: Google File System, Google MapReduce, and Google Bigtable. So Google search engine, as you are aware of, it crawls over the web pages in the internet, and it applies algorithms like page ranking and all those things. And then when you try to search based upon the page ranking, the search results will come up. So that is the main algorithm of Google. And if you think about the characteristics of this algorithm, Google has to crawl lots of data and dump into a file system. And at that time there was no distributed file system. The characteristics of data is not operational. It is more of a batch process where it has to get the data in timely manner from all the web pages and dump into a file system. And as there was no proper solution, Google thought of creating a distributed file system where this data will be distributed across many nodes in the cluster. And then to process the data and apply the page ranking and all those things, they have come up with a concept called Google MapReduce. And these two things will coexist, and these two things will be deployed on hundreds and thousands of the nodes in the cluster. And as the Google MapReduce and Google File System coexist, uh, uh, it eliminates a lot of network I/O and try to process as much data as possible locally where data exists. So Google File System is a distributed file system which is deployed on hundreds and thousands of nodes in the cluster, and Google MapReduce is a distributed computing framework which is deployed on the same nodes where the Google File System exists. So Google File System is used as storage, MapReduce is used for batch processing, and once the processing is done, they have dumped this data into a data structure called Google Bigtable, which is key value pairs, which have implemented key value pair concept, and it will be sorted by key automatically while the data is being stored. And then when you try to search, it will go to the Bigtable, and as the data is already indexed based upon certain keys, it can fetch the results as fast as possible. So Google came up with these three technologies: Google File System, Google MapReduce, and Google Bigtable, and they have published white papers out of it. Before getting into more details about those white papers, let us think about the characteristics of big data. Take the example of Google again. Yeah, it has to crawl a lot of web pages and it has to capture tons of data. The volume is very high, and as it has to crawl the web pages, data is not structured. So you have both structured, semi-structured. structured and unstructured data, and also you have the hybrid semi-structured data spread across the internet. And then the velocity. So the data that is loaded into GFS has to be processed as quickly as possible, and the page ranking and all those algorithms has to update at regular intervals, so that you get the results that are relevant to that point in time. For example, if you are going through election campaign, and if someone want to keep track of primaries results, it has to be the results have to be searchable as soon as primaries are done. It should not come after a week or 2 weeks, and by the time elections might already be over. So getting the search results relevant to that particular point in time by reducing the latency is very important. So that's what velocity that's what is velocity. So these three are the primary characteristics of big data: volume, variety, and velocity. Typically, whenever you have at least two of these three characteristics uh, applicable to a given data set, you can start thinking from big data perspective, and you should start evaluating the big data tools, and include that in your roadmap of IT application development. And from enterprise perspective, we want to process data in batch. We want to process some data in real time, which is operational, and then you might want to run analytics out of it. So the entire big data ecosystem can be categorized into three. One from application perspective, one is batch, and Hadoop ecosystem works very well for batch processing, especially tools like MapReduce, Hive, or Pig, Scoop. These are all MapReduce driven tools, and these work very well for batch processing applications that require batch processing. And then from operational, we have tools like Cassandra, HBase, and MongoDB. Again, HBase is part of Hadoop ecosystem, so there is an overlap between batch and operational. And Cassandra and MongoDB are other two NoSQL databases uh, uh, which can be leveraged for operational but not transactional applications. Keep in mind at this time that we are not there is no alternative for transactional systems in big data ecosystem. If you want to implement a highly transactional based application, then you have to fall back to the proven legacy architecture of NTR, where you use RDBMS for databases, application servers for application logic, and the browsers as clients. So you can fall back for that for regular transactional systems. But if the use cases are operational but not transactional, you can start evaluating these NoSQL databases. And if it is about batch processing, you can start evaluating Hadoop ecosystem. And when it comes to analytics and visualization, this is still evolving, and primarily we do sentimental analysis, statistical analysis, machine learning, and natural language processing. So these things comes as part of analytics and visualization of big data ecosystem. As this is more towards infrastructure and application development, as part of this introduction, we will not see much about analytics and visualization, but we will talk about batch and operational in detail in coming slides. Okay, so what are the big data ecosystem advantages? It uses distributed storage, so data will be distributed in a particular fashion. Again, for NoSQL, it distributes using a different logic, and for Hadoop, it might use a different logic to distribute the data. And for fault tolerance, RAID, which is typical in enterprise technologies, is replaced by replication. Okay, so and for distributed computing and processing, it uses data locality. So as I have explained in our previous slides, our traditional RDBMSs, data comes to code over the network switch, and it can become bottleneck. Either network switch can become bottleneck, or your database servers themselves can become bottleneck. Whereas when it comes to distributed computing or processing in big data ecosystem, uh, code goes to data and it is called as data locality. So we will see that how it works in later slides. And scalability is almost linear. In Oracle we have seen that the below blue line is for traditional RDBMSs. When you try to add more and more database servers to your cluster, and the scalability is not linear. For example, if you have one database server and if it can support 1000 users, with two database servers it might be able to support only 1500. With three database servers it might be able to support only 1800. With four database servers it might be able to support only 2000. And after that it might even not scale. Means even if you add more database servers, it might even start supporting lesser than 2000 users. So it will reach a threshold, and the curve can even go down. Whereas with the big data ecosystem, the scalability is almost linear. So it will not be in the at this level of the red line, where the scalability is linear. With the big data ecosystem, you can visualize the scalability like this. With one server, if it is supporting 1000, with two it might support 1800, and with three it might be able to support 2600. With four it might be able to support 3500. So the scalability curve can be like this. So it will be much better than the traditional RDBMSs, and it is very uh, close to our linear curve. Okay, and we use commodity hardware, and each server is ranges between $5,000 to $15,000. So it's a very low cost hardware and low licensing costs. Most of the software is open source, so you need not pay for your softwares. Whereas in traditional architecture, you have to have expensive storage clusters. You have to have expensive hardware, like IBM P series computers, or Sun Solaris servers, high-end Sun Solaris servers, or even high-end HP servers. Whereas in big data ecosystem, you typically use low-cost hardware, and it ranges from $5,000 to $15,000. And if you think about traditional applications, you have to pay for software at storage level, for software at database level like Oracle, for software at application server level like WebLogic, etc. So you have very high licensing costs in traditional enterprise applications using traditional architecture. Whereas in big data ecosystem, licensing costs are almost zero, because most of them are open source. Okay, that is about big data ecosystem at higher level. Now we will get into more detail, starting from uh, more, now we will start getting into more details, and next video will cover about Hadoop ecosystem, which is part of big data ecosystem. I hope you enjoy the session. um, have, we will catch up in the next video.